Let me start our next session with how to convert any number base system into a decimal number system and from one base system to the other base system. So now binary to decimal conversion. How to do this? So that we are going to discuss. So if they give you the binary number and they ask you to find your decimal number equivalent, then what we need to do is we need to take each bit of your binary number and it has to be multiplied with its positional weights, where the positional weights or the weight of the binary number depends on your base position of your that particular bit. So base positional weight depends on your where the bit is placed in your given binary number. So multiplying your each bit with a 2 power n, where n defines the weight of the bit and the weight is the position of the bit starting from your 0 on the right. Add the result, then we would obtain the equivalent decimal value. So now identify which bit is your having a positional weight of 0. So start from there and multiply with its positional weight. As in the given example, I have given a number with a total 6 bits and they wanted to find what is the equivalent decimal value. Now here let us start. The least significant bit position is 2 power 0 and here this one is at 2 power 1 and this 0 is at 2 power 2. This one is at 2 cube and here this 0 is at 2 power 4 and this one is at 2 power 5. So by multiplying your each bit with its corresponding positional weight, we would obtain a product and adding all the products will get your equivalent decimal value. 1 into 2 power 5 plus 0 into 2 power 4 plus 1 into 2 cube plus 0 into 2 square 1 into 2 power 1 plus 1 into 2 power 0. As 2 power 5 is 32, 0 into 2 power 4 is 0, 1 into 2 cube is 8, 0 into 2 square is 0, 1 into 2 power 1 is 2, plus of 1 into 2 power 0 is 1 into 1 is equal to 1. Upon adding all the products, we obtain the equivalent decimal value, which is 43 to the base of 10. Now, let me take another example of conversion with a mixed number where it contains the binary number contain both integer and fractional part. So 111.101 to the base of 2. We already familiar with that. Integer part positional weights are positive. Fractional positional weights are fractional part positional weights are negative. So let me start with identify your where the least significant bit position on your integer and what will be the most significant bit position of your binary number, and in your fractional part which one is your least positional weight of your fractional and which one is your most positional weight of your fractional part of your binary number. So now 1 into here 2 power 0, 2 power 1, 2 power 2. So hence 1 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0 plus of, so 1 into in a fractional part 1 into 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3 is equal to, so upon multiplying your each bit with the positional weight, we would have a product which is 4 plus 2 plus 1 plus 0.5 plus 0 plus 0.125. The exact summation of these all the products will give you the 7.625 to the base of 10. So this is the equivalent decimal value of your given mixed number. The same manner, you are going to convert your given octal into a decimal by multiplying your each digit with its positional weight. So in my given octal number, I have given 3 digits. So in that 3 digits, the least positional weight digit is 4, the most positional weight is 7. So 7 is multiplied with 8 square, 2 is multiplied with 8 power 1, 4 is multiplied with 8 power 0. Upon multiplying all these, we will get obtain your product, which is 448 plus 16 plus 4. The exact summation of 448 plus 16 plus 4 is equal to 468 to the base of 10 is the equivalent value of your given hexadecimal octal number 724 to the base of 8. So next we are going to convert your hexadecimal into its decimal conversion. Like in octal and a binary, each digit of hexadecimal number is multiplied with its corresponding positional weight. So first example will be a pure integer form. So a into 16 power 6, 16 square, b into 16 power 1, c into 16 power 0. As the a alphabet equivalent decimal value is 10, so in the next step replace the alphabets with its equivalent decimal value. A is replaced with 10, B is replaced with 11, C is replaced with the 12, and we obtained your actual summation of all these individual products is 2748 to the base of 10. Next, in the second example, we have been given with a mixed number of 31 point into d2 to the base of 16. So 31 point d2 to the base of 16. So now the least digit in your fractional number is your 2, and the most significant digit of your integer number is 3. So 3 into 16 power 1 plus 1 into 16 power 0 plus d into 16 power 1 plus 2 into 16 power 2. Upon multiplying each digit with corresponding positional weight, we obtain the equivalent decimal value is 49.8203125 is the equivalent of your given hexadecimal number. So this is about how to convert your any number system into decimal. So we are going to use the common procedure to convert any number system into decimal by just multiplying each digit of any number with its positional weight and adding all that products would give you the actual equivalent in your decimal number system. Next, let me move with the how to convert from one number system into the other number systems. So now, like binary to octal conversion. So there was a direct conversion. We have direct method and an indirect method. Indirect method. So binary must be converted into your decimal and then from decimal to octal. But we would also have indirect method. In that indirect method, when you wanted to convert a binary number into an octal number, let me group 3 bits of your each. We have to take all the binary numbers, and then upon taking all the binary numbers, grouping your 3 bits as your as will give you the octal digit. So each group of 3 bits can represent one octal digit. As I have given here, total 5 bits in your integer and 2 bits in your sorry 5 bits in your integer and 2 bits in your fractional number. Let me group your binary bits as taking 3 bits as one group. So we start the grouping if it is an integer part from your left side, if it is a fractional part, from the right side. So this become the first group and this become the second group. As you don't have the third bit, you can consider or you can assume the third bit must be a 0. So 010 is equivalent to 2 in decimal, 110 is equivalent to 6 in your decimal. Decimal equivalent we need to write it as here 010 is 2 and 110 is 6 and here 01. So the rightmost bit is not at all there, so you can assume a 0 in this. Then this become a 2. This become a 2. So equivalent value of your binary 10110.01 in octal is equal to 26.2 to the base of 8. Next, in the same manner, how to convert a binary to hexadecimal is by grouping 4 bits as one group. So now let it take, this is the first group. I've started your grouping from your left side if it is an integer, from your right side if it is a fractional. As you doesn't have the three zeros, so you assume the three bits as a 0, then it become 1. Here 0 1 1 0 become 6. Here rightmost bits are not there, so we have to assume this as a 0 0. Then we would obtain your 4 here. So equivalent value of 10110.01 is equal to 16.4 to the base of 16. So in this way we will convert a binary into a hexadecimal number system. Next, how to convert a octal into a hexadecimal conversion. Now, so an easiest way method is converting first your given octal number into binary and then binary to hexadecimal number system. As in the given example, we have given 26.2. First, write the equivalent binary value by taking your each digit with the 3 bits. So 3-bit binary. So 2 is represented with a 3-bit binary 010. 6 is represented with a binary of 110. 2 is represented with a binary bit of 010. Next, upon having the binary equivalent, now let me group your given or the equivalent binary by taking 4 bits as one group and writing your equivalent hexadecimal value. So first 4, so we'll give you the 6 equivalent and then next to 2 bits you can assume the zeros, additional zeros of 2, then it become 1. So next here 0 1 0, it doesn't have a one more bit which is the fourth bit, so assume on the right side a 0, then it would become 4. So equivalent value of octal 26.2 to the base of 8 is equal to 16.4 to the base of 6. So this method of conversion is called an indirect method, an easiest way of converting your given octal into hexadecimal. First we need to convert your given octal equivalent into binary, then binary to hexadecimal conversion we need to prefer for obtaining the equivalent hexadecimal number conversion from a octal number. Next, how to obtain or how to pronounce the powers of 2. So here we have 2 power 0 is equal to 1, 2 power 1 is equal to 2, 2 square equal to 4, 2 cube equal to 8, 2 power 4 equal to 16, 2 power 5 is equal to 32, 2 power 6 is 64, 2 power 7 is 128. Now 2 power 8 is 256, 2 power 9 is 512, 2 power 10 is 1024. This is also called as a kilo. 2 power 11 is 2048, 2 power 12 is 4096, 2 power 20 is called 1 mega, 2 power 30 is called 1 giga, and 2 power 40 is called 1 tera. So this is about our number base conversions from one number system into other and other base conversions.